Okay. Good morning, everyone. Welcome to the third of our 2022 series of webinars, where we'll be discussing the GaStim PM and the GaStim Cond. Um, I'll be making this presentation so it can be recorded on the YouTube platform, and we are currently live streaming uh, through YouTube and through Google Meet. Beforehand, I would like to ask of you to please mute your mics. If you have any questions, please make them at the comment section of the Google Meet platform. And at the end of the presentation, we can have a discussion on any questions or requirement that you may have. Okay. So this will be the outline that we'll be managing for today's presentation. We grow through a recap on the gasting concept, which was the topic of one of our previous webinars. Then we'll go discussing the GaStim Cond, then the GaStim PM, and we'll finish with a discussion and the webinar schedule for 2022. So, but first of all, let's talk a bit about GaStim technologies. Here at GaStim Tech, we consider ourselves more than anything a technology company, providing novel and most importantly, proven solutions for the oil and gas industry. The company was officially um, formally introduced around 3 years ago. We're based here in Bogota, Colombia, South America. And our technology and consulting portfolio is based on our experience and innovation as pillars to provide high quality and sustainable value in mainly three different levels. The first of our main pillars that we offer in our business strategy is the design and deployment of an unique gas-based technology, which is GaStim for well productivity and recovery enhancement, IOR or EOR. The second of our main lines that we offer here at our BD portfolio. Good morning, everyone. Good morning. Welcome to third of our 2022 series. Okay, I think I got it over here. Okay, okay, got it. So, as I was telling you before, the second one of our pillars that we offer at our business portfolio is the maximization of the asset value. Basically, the experience that we have here, GaStim Technologies on our team, we have the knowledge and we apply proprietary integrated asset evaluation workflows in different topics. For example, in the diagnostic of the reservoirs, uh, wells and surface facilities, restriction, support and implementation of best practices and proven technology to maximize the overall deliverability of production systems. So this basically refers to the different consultancy schemes that we may offer here at GaStim Tech. And finally, the third one of the main pillars that we offer here is the specialized training. Taking taking advantage of that same experience, we offer different specialized training and courses in the topics of well productivity, formation damage, IOR, EOR, applied nanotechnology, and gas injection recovery and geomechanics. So this is a quick summary of what GaStim Tech is and what we try to offer into the industry. So moving on, um, I will talk about the gassing concept. This was the main topic from our first webinar, but it is pertinent for this webinar to make a quick recap of it. So the gassing concept was formally introduced around 2012, around already a decade ago, meaning that the technology has been developed and on the works for over 10 years now. And it basically consists on introducing chemicals into the gas stream in order to build and stable chemical and gas dispersion. So by accomplishing that chemical and gas dispersion, we can see great advantages and positive effects when we compare it to conventional liquid-based applications. Um, so the conventional liquid-based systems have been summarized in like acidizing solvents or alcohols. And if you can see the top left graph, when we go with those liquid batch systems, we have way lower treatment radius. It usually we can usually get to 10 feet into the reservoir, or probably 10 feet at most, 20 feet at most. However, when we use the gas as a treatment carrier, we can get way deeper into the reservoir, overcoming the hundreds of feet into the reservoir. So we will have a greater simulated reservoir volume. And this is basically because the volumetrics of the gas systems are way more efficient when we compare it to liquid based applications. And what this translates into is that the chemical will be in place in a much greater area of the reservoir, leading to an enhanced treatment coverage and distribution, which also translates in a higher durability and a better flowback efficiency of the treatment. Another characteristic and advantage of implementing a gassing type treatment is that we will have an improved injectivity. This is especially useful for low permeability formations and low porosity formations where the pore diameter is very small. In some cases, when we apply liquid treatments, we may found the chance of inducing a formation damage and blockage due to just the pore size, and that's where the other advantage comes through is that we'll have a lower risk of inducing damage into the reservoir. Basically, the gas is a way more friendly um, carrier for treatments in general. So as you can see again in the lower left graph, the treatments are way more are higher when we compared it with some conventional liquid-based applications. And again, all gas in tech solutions are designed according to the rock fluid environment. All our solutions are go through a deep um, laboratory protocol assurance, modeling, and diagnosis before we make any stimulation and intervention. In the right of this slide, you can see what consists a typical surface facilities scheme of a typical gas type treatment. We basically have a chemical storage, a chemical pump, a gas source which can be nitrogen, CO2, flue gas, or in most cases, and it's probably the the most effective option to the moment is hydrocarbon gas, a chemical injection system, the wellhead, and in some cases the separator may be needed, but it's not a mandatory uh, element of the surface scheme for all design treatments. Also to note here is that here at GaStim we've been developing a real-time monitoring system to make a quick surveillance on all those parameters of the chemical intervention in real time. So this is the main portfolio of solutions that we offer here at GaStim. In our previous webinar, we discussed the GaStim diff, which is our foam treatment aimed at improving conformance in gas injection projects. As we discussed there, we introduce the foaming agent directly into the gas stream so we can generate the foams directly into the reservoir. As we discussed there, the applications of the GaStim DF is applicable to both matrix and natural refractory reservoirs, as several of our pilots have shown. And again, it showed way more advantages and positive effects when we compared it to different conventional liquid base applications in these foam treatments, which has been um, like surfactant and gas injection. We'll be discussing the GaStim Cond and the GaStim PM in this webinar, and in our next webinar, we'll be discussing the GaStim Solve. So, moving on into the GaStim reservoirs around the world. And it happens because the pressure of the reservoir falls below the dew point. So, as the pressure falls, it starts to fall, the saturation of liquid condensate starts to increase. And because the drawdown and the pressure profile that is generated, this damage will be more severe in regions close to the wellbore. That's where we can identify different regions with different saturations of this liquid condensate. And the thing here is that that liquid condensate will generate a blockage and will impact the gas deliverability of the system. So removing and inhibiting that liquid condensate, it's very critical in some projects. With GaStimCond, we can precisely accomplish that. And again, it will have all the advantages that we discussed at the GaStim concept, which is an increased stimulated reservoir volume and thus a bigger condensate recovery. Will have longer durabilities due to a deeper emplacement of the chemical and enhanced chemical absorption, and it will enhance the hydrocarbons mobility due to an interfacial tension reduction. So we basically try to introduce a surfactant type of chemical that will mobilize that liquid condensate system. If we go to the top right of this slide, we can basically see that with the GaStimCond, we will have a shift in the relative permeability curves, enhancing the relative permeability curve for the gas and impacting the relative permeability curve for the oil, getting a higher normalized permeability with the GaStimCond method when we compare it to the liquid batch applications. And also very important thing that I want to mention here is that if you see on the lower right part of this slide, the lower right graph, with the GaStimCond, you will need way less chemical concentration when we compare it to, for example, a conventional gas and alcohol liquid-based treatments, and this will translate in better economics of the projects and a more efficient uh, intervention and job as well. Mm. So um, here at GaStimTech, we've developed our own proprietary engineering toolkit and analytical tool for simulating this type of treatments, which is called the Gasnotics. It aids with our everyday operation, and it helps to model these IOR and EOR processes. But before I go into more detail of some applications, I just want to mention here that if you see on the top right graph of this slide, that graph refers to previous liquid-based applications that our team at GaStimTech have some experience into. And what it basically tells us is that yes, in some cases the liquid-based treatments will show good results. However, when the grade of depletion of the system is very severe and very high, the durabilities of those liquid batch applications will be very poor. And that's when we will need a gassing type treatment to impact a deeper portion of the reservoir. And when we inject the gas, we don't only provide the system with a deeper rate of penetration, but also we'll be energizing the system, which is one of the methods for um, inhibiting this type of damage. So moving on with our gas and con treatment modeling, as you can see, our model basically incorporates some sorption kinetics necessary to model these type of treatments that not all commercial uh, modeling tools known to the industry takes into account. And when we compared it with the real data results of our field implementation that you can see on the lower right. It's a treatment where we injected about 600 million SCAF throughout 9 days. Throughout 9 days, and we see that the treatment effects, positive incremental results, mm, lasted for about a whole year, and that is a very great number when we're talking about treatment durabilities here at the industry, giving us an incremental production of between 28 and 30% of incremental hydrocarbon production. And with our GaStim Cond model, we could see a prediction error uh, of less than 10% on the gas forecast. So this will be again a brief summary of what we offer at the GaStimCond. Um, I'll start now the discussion on the GaStim PM. So water intrusion and water control is something very critical in some wells here in oil and gas fields, especially because the water, I'm sorry, will affect greatly uh, the well's life. I mean, the economics as the saturation of water starts to increase, become more and more marginal. For example, it is usually throughout the graphing of a non-flow envelope of water gas relationship versus gas liquid relationship, where we can see like a limit on the well's life. And with the GaStim PM, which is a relative permeability modifier, we can impact the relative permeability of the water and reduce its production. And so we can move the well far away from that known flow envelope, enhancing the well's life trajectory. So the GaStim PM as a relative permeability modifier is a nanoparticle. It's a nanotechnology based system, and it basically tries to create and emplace a nanoparticle film in the reservoir. It's a very hydrophilic film that is generated and placed into the pore system, and it is what impacts the relative permeability for the water. Um, if you see the top right graph, you will start to see that again the advantages of the of this type of gas implications start to show. With the GaStim PM, we can place that nanoparticle film way deeper into the reservoir when we compare it to conventional liquid-based applications. And also, when we get to the most optimal treatment concentration, which is designed at laboratory scale prior to any operation, we can see a maximization of not only the reduction on the water effective permeability, but also maximization on the gas effective permeability. So not only the system will start to see a reduction on the water production, but also you start to see an increase in the gas production. So this is the main added value to this type of technologies. When you see the conventional systems in results, you will see a very brief re, re- a very brief reduce on the BSW percentage, and you will go back to the baseline BSW that you were seeing before. So the durabilities are very limited, and this is very because the penetration of those liquid-based treatments again is very low, and the volumetrics that you're managing are not that efficient. Um, as you can see, basically in the top left graph, when you go analyze the bottom left graph, you will see two different fractional flows curves. Um, one is the yellow one is the fractional curve before any type of treatment, and the blue one is after treatment. So the the important the key idea here is that the the maximum difference between those fractional flow curves happens at a saturation at a water saturation level value around the middle, very close to the deeper into the reservoir, basically. We'll have lower water saturations close to the reservoir, and in those water saturation is that the liquid conventional systems will see its results. However, the GaStim PM system will see its results in a region between the near wellbore and the aquifer region where we have a 100% saturation of the water, and it will see its greater results in that system. So that's one of the reasons why it's very important to have a deeper treatment radius to see the most effective results for this type of relative permeability modifier treatments. We can see some modeling results from our laboratory assurance based on the laboratory results on the top right. And as most of our GaStim technologies, the field implementation for both the GaStimCond and the GaStim PM can be applied to either single well scheme, half and puff, IOR, and it can also be applied in an interwell EOR deployment scheme. Okay, so that would be the main information that we have here for you guys today. Again, thank you so much for your attendance. If you have any questions, please leave them at the comment section in the Google Meet section. And as a reminder of our webinar schedule, on the 14th of July, we'll be talking about the gassing solve. Okay, so thank you very much for your attendance.